Hello, this is the Universal Mind Channel, and this is episode 10 of our study of reincarnation, the scientific theory, from my book. Now, Phi Alpha is what we call it now. We don't call it reincarnation because it's a serious field. It should be studied seriously. It shouldn't have a hocus pocus name anymore like reincarnation. It should have a name worthy of scientific research, Phi Alpha. Phi Alpha is a natural process in which human physiology, adapted by eons of evolution, obeying fundamental universal laws, conserve and preserve the information that make us who we are. Our memories. Without our memories, who are we? We exist. Our existence is defined by our memories of our existence. Our memories are the reflection we see when we look out into the world. Because every second of every minute, every day, every year of our lives, our existence is dependent upon our memories for self-validation, that we exist. Me talking to you, I rely upon memories of myself talking to you as I'm talking to you. And so do you. You do the same thing all the time. Memories, like every other bit of information, cannot be destroyed. Like energy and matter, there's a conservation of information law that prevents information from being destroyed. Who you are cannot be destroyed. Your body dies. But the information within you that makes you you, your body's just a host. You carry with you who you are from life to life to life. And this book, this series of lectures, is about the process, I believe, it's a theory, of how this transfer of information from a dying body to a living body occurs. And we're about done. Next episode, maybe the next 2 episodes, depending upon how fast we get through it, will be upon where that information goes. This episode ends how the memories are processed within the dying body and emitted out. We'll finish that today. The next episode or 2 will be, because it's very complex, but you'll find that it's very fascinating and thought-provoking about how the information of who you are is transferred into another body. So let's start, shall we? We're near the end of the Phi Alpha process within the dying human host. In our theoretical model, the individuality-carrying memories have now been encoded upon biophotons within the hippocampal sulcus. If you remember from past episode, the hippocampal sulcus is a pocket within the middle, the core of the brain. This packet of biophotons is now ready to be released or emitted out of the dying body. As we discussed earlier, biophoton emission out of the body would be controlled by quantum mechanical effects and may even involve what researchers term quantum teleportation. We're going to learn about quantum teleportation now. Back in 1998, 2 professors and their team, Professor Furusawa and Sorenson, reported the first successful experimental quantum teleportation of photonic energy states. In 2016, a separate research team reported successful teleportation of entangled photons over a 30-kilometer optical fiber quantum network. Also in 2016, the team of Raju Valivarthi and Marcel Puigibert reported the successful quantum teleportation of a telecommunication wavelength photon interacting with another photon over 6.2 kilometers. Applications of this research in the telecommunications industry included extending quantum communication distances using quantum repeaters that rely upon the light-matter photon entanglements. The concept of quantum teleportation is complicated, no doubt, but its origin arises from a logical inference of quantum mechanics. The teleportation aspect of the concept is not what messes with our minds. Most of us are familiar with teleportation from the Star Trek series. It's the quantum mechanical component of the term that messes with our heads. Quantum mechanics is part of a universe we humans lack the ability to experience with any of our five senses. We can't see or smell, hear, touch, or communicate with the quantum mechanical part of the universe. This is so because the realm of quantum mechanics is limited to only those forces in matter so small that they're referred to as elementary particles, or wavelengths of light that we cannot see. Elementary particles are so small they can only be studied by special machines called particle accelerators, like the Large Hadron Collider over at CERN in Europe. The first serious consideration of the subject of quantum teleportation, believe it or not, was back in 1935. It was in a thought experiment that was put down on paper by Einstein, Podolsky, and Rosen back in 1935. Their article was entitled, "Can Quantum Mechanical Description of Physical Reality Be Complete?" Quantum entanglement is one of the weirder applications of quantum mechanics and theoretically creates, as Einstein described in that article, quote, "spooky action at a distance," unquote. To illustrate what Einstein meant by spooky action at a distance, let's consider the following scenario. Two photons interact and become entangled. How do they become entangled? Under severe pressure, intense pressure like that of the sun, intense pressures and heat. They join, they become one. Photons, we know, carry information. They absorb, carry and emit information all the time. From the dawn of time, from the beginning of the universe, this universe has been flooded. The universe is bathed in photonic energy. And the information those photons carry and share. One could almost say to you, can't you understand how universal consciousness was created by the energy field of coherent thought by entangled photons, sharing information with one another. So, with that, consider this. You've got two photons. They become entangled, and then they each fly off in separate directions at the speed of light until they're at each end of the universe. So they're that far away. If you study one of those entangled photons, you instantly know everything about the other photon that's on the other side of the universe, despite the fact that the fastest anything we know the fastest anything can go is the speed of light. But if you've got two objects and you can learn about one from the other instantaneously, and they're each at the other opposite sides of the universe, that is the speed of thought, which is instantaneous. How can that happen? That's why Einstein called it spooky action at a distance. And we're only now beginning to understand what that might mean in entangled photons and teleportation. This action is described as spooky because it implies that with entangled photons, information can travel instantly, regardless of the distance separating them, in apparent violation of the laws of classical mechanics stating nothing can travel faster than light itself. There's nothing spookier than the idea that quantum entanglement allows light waves to travel across intergalactic distances instantaneously, as well as the information they contain. Several questions pose themselves at this point regarding phi alpha emission. How much information can one photon carry? How many photons are needed to encode phi alpha memories? How many biophotons could be stored in the hippocampal sulcus and emitted together as discrete phi alpha before emission? How would this phi alpha matrix be emitted? As a collection of joined particles, or as a wave, or series of waves? Where would phi alpha be transmitted? How would it get there? Well, these are all critical questions worthy of serious scientific study, but there is no afterlife science yet. And until there is, we won't know, will we? No, we won't. However, we should begin to review some basic information now. Photons, a little study of photons. They're elementary particles. They have zero rest mass. They have no mass. And they're always traveling at the speed of light. Like electrons and other elementary particles, describing photonic behavior, including biophotons, is restricted to the abstract logic of quantum mechanics. Photons are subject to what's termed wave-particle duality. They act as particles at times and other times waves. However, the famous physicist and Nobel laureate Richard Feynman believed both the wave viewpoint and the particle viewpoint were inaccurate. An accurate description of photonic particle and wave properties is very complex. While this subject extends far beyond the scope of these lectures and my book, his lecture on the topic archived at the California Institute of Technology is well worth studying, and it will be cited in the description following this episode. We know from our earlier discussion of quantum entanglement that photons can be measured as entangled particles. We also know photons are measured in the electromagnetic spectrum as waves whose wavelengths vary with frequency or the energy of the photon, which determines the colors we see in the visual spectrum. So let's accept as true that photons are both particles and waves relative to how we interact with them. For example, you take a look at an ocean. What you see are waves because the particles are all entangled together so tightly you can't discern one from the other. But as soon as that wave interacts with matter, a shore, rocks, that wave becomes spray, individual particles of water separated from the wave. So you're seeing a wave component to an ocean as well as particle component to an ocean. Is light like that? Maybe. It may depend upon how we perceive, in what way we perceive photons, and how they interact with matter at the time we're perceiving them. A promising starting point for further research in this area should focus upon the correlation between the Gyru-Sulcus fold wave pattern and photonic wavelength. We do not believe it possible for the neural net ions to travel from neuron to synapse, back to neuron through wavelength axonal channels without absorbing an energy signature matching the wave path they traveled through the cortex. However, it is possible that a simple act of measuring phi alpha might be enough to destroy its energy coherence. In effect, it might prevent us from being able to measure it at all. We'll just have to try it and see. Because ultimately, the fact that phi alpha, the emitted particles as they leave the body, have a frequency and a wavelength, provide us with the opportunity to measure that and observe it, and thereby obtain evidence, smoking gun evidence of reincarnation, aka phi alpha. Because if we can measure the wavelength and the frequency at which these particles are emitted out of the body as the body dies, whether it's a pulse or a continuous wave or just one pulse of energy, that may be the smoking gun. The question is getting the scientific instruments sophisticated enough to be able to measure them. We may not have that now. But ultimately, that will provide, I think, the smoking gun evidence that reincarnation, phi alpha, exists. That's all for today. Next time, we'll take a look at how a new body, an unborn body, absorbs photonic information from a dying body. That'll be episode 11 and maybe 12. We'll see how far we get. That's all for now. Thank you so very much. Oh, by the way, if you wish to contact us, we can be contacted through the Universal Mind Channel at gmail.com. That's the Universal Mind Channel at gmail.com. Almost forgot. Take care.